Welcome to Friday. Congratulations on surviving so far.
I don't want to.
It doesn't mean go get Rona. Just FYI.
That makes two of us.
Okay. You know you're in college and you start making self-deprecating jokes like that, though. So, yeah, welcome.
That's just Gen Z.
I don't know.
That's us as a whole.
Us millennials did the same thing, so.
Well, yeah, but I'm saying it's not just college students that do it. It's like our entire generation. That's what we're all about.
Yeah.
It's true. Boy, this is not.
Self-degrading jokes.
I mean, it doesn't help that the environment and economy is going down the shitter, so.
So on a positive note, let's go ahead and today's going to be our last lecture, kind of summing up the scientific method. We've been talking about this now for the past 2 weeks. What I thought would be a good fitting end to our discussion would be to actually walk through a faux scientific method process. Now, I'm going to be making up data for you based on what I actually know. But we're gonna walk through this together just to kind of give you an example of how it's done. Now, the ultimate goal of what we're doing here is that hopefully it would give you insight into how your process is going to go when you design your experiment. Okay? Similar, same kind of situation. So we're going to start with an observation. Okay, now what this observation is, do any of you have parents that have solar panels on their property?
No.
You do? Anybody else? Okay, that's a no. Well, have you ever played around with your parents' solar panels? Yeah, they're actually kind of dangerous, so that's probably a good idea.
Yeah, I just play with solar panels.
I just touch wires.
Yeah.
Every once in a while I touch my tongue like a 9-volt battery. By the way, yeah. From a solar panel?
No. You're talking about it like you keep talking about a 9-volt battery as if it actually like causes damage and hurts and like come on, man.
Okay.
You gotta make
I'm
sure
getting
it's
weak at my old age, all right? 9-volt batteries, they hurt. It's uncomfortable.
How else are you gonna make sure it's still charged?
I'm going to go hug my Dr. Scholl's insoles after this class. You've so thoroughly hurt my feelings. I wish these were Velcro. Anyways, by the way, just as a fun fact, there are people who die every year because fire teams that are cutting into houses cut into electrical wires coming from solar panels and electrocute themselves. It does happen. Ironically, if you look at the death rate, the number of people who have been killed by nuclear power is significantly less than the number of people who have been killed by solar panels. Yeah, I had a student do that in this class 2 years ago. They showed me that, and that has stuck with me. In any case, so as we're talking about solar panels, let's say I plug in my solar panel, and being the astute scientist that I am, what I end up doing is I note that the solar panel isn't putting out very much power, even though the sun is up.
Cover off of it.
Is it not seeing the sun? Oh, I got it upside down. That's terrible. That would completely negate my whole I am an astute scientist thing. Doing problem solving. This thing's not working. I'm gonna kick it. Okay, so what I do, at being the astute scientist that I am, is I plug in a voltage reader to my solar panel so that I can determine how much volts are being produced or how much power is being produced by the solar panel through a one-day cycle. Okay? So here it's night, and then it becomes morning, it gradually increases, and then at some point it peaks, but then it goes back down, and then it's night again. At nighttime, you don't expect to be getting very much energy at all. There is a little bit that comes off of ambient radiation, a little bit that just naturally happens. But at nighttime, you get very little amount of power. Yeah. So this by itself is not terrible, right? I mean, you get a nice good peak. You expect that, full sunlight. Well, the problem is, and the observation that I'm making, is that if you compare this to the solar radiation, for that same 24-hour period, you have nighttime, but it gradually increases to this point, and then cuts off, and then like that. And the question is, why are these two different? That's, yes, that's a good hypothesis. You're getting ahead of me now. Let's go through the scientific method. We've now made an observation. What's the next step?
Background knowledge.
Yeah.
Background knowledge and ask a question and do research. So what we'll do now is we'll ask a question. What question would really encompass the observation that we made here? Why is the solar panel not capturing all of the available power?
Why doesn't that look like that?
That's a very scientific question. Why does that not look like that?
It works. We all know what I'm talking about.
Okay, so here's a question. Is this a good question? Why is this a good question?
Because it encompasses what we're trying to figure out and at the same time gives us a viable direction to focus and see where the problems are.
It gives a good focus because it directly references the observation that was made. Okay? It's not capturing everything because something is being left out. The peaks do not match. Okay? So, there's one question. Now what's the next step? This is where you jump in, Jace.
No.
If you say coffee, I'm going to kick you out of the room again.
What?
All right. Well, fine, since Jace won't say it again. I'm going to say it for you. This is where we do background research. Go ahead and plug this question into Google. We'll do very...
In the Internet Explorer.
No! All right, that's right. That's where I kicked you out of the classroom last time.
Safari is the only
Yeah, you
thing
never
I've
kicked me
built
out
right
for
now.
coffee.
That's true. That's true.
Now you almost kicked me out because I said you should try iced coffee.
I may be bipolar. You probably know this by now. Yeah. But the Internet Explorer, that's inexcusable. It's gross. Okay, so what I want you to do is just give me some insight. What guidance is there online about this question? Yeah.
Okay, so one of the first things that I found that's pretty prevalent is that is problem, also known as zero power output, can be caused by a damaged inverter or a faulty charge control.
Okay. So there's one piece of information. Yeah.
Air pollution can reduce power, so like how close and friends are you with the Lorax right now?
You know, right now he's out there speaking for the trees, but we have a meeting after this. Okay, what other information is there?
Your geographic location can have an effect on that as well. It also appears that the season and the local landscape has some effect on it.
That's what we should do. We should, instead of having solar panels on Earth, we should just send a rocket up with solar panels all around
And
it
bring back the
and
sun.
have a wire that just drops from the space shuttle down the Earth. And it gets a direct solar radiation, no filter.
Bluetooth energy. Whenever it tears up, when it tears up, just start pulling and pulling back to the earth.
Dang.
Actually,
Gotta reel in this kite again.
glass, or just like the drop-in chargers for phones, I wonder if there would be a way to do that long distance.
Everybody's been looking for that. And it's, if you could figure out wireless power transfer, you could be a millionaire.
Who wants to be a millionaire? How do you
Yeah.
do this?
It's the way that doesn't involve Regis. Although Regis is dead, so. Okay, we're still doing background research. I can promise you, you guys don't know very much about this problem yet. Yeah, Duncan.
It actually says on this that warmer temperatures have an adverse effect on things.
Yes.
So it like downgrades the solar cells.
Okay, who else had something? Go for it.
The orientation of the
Okay. Yeah. Weather. Weather conditions. All right, let's go ahead and I'm gonna break quickly. What we've managed to do here is we've managed to come up with a really good starting list of variables that influence the power. Okay. Let's say we want to know a little bit more about this one. How does the orientation of solar panels affect the power input? Because, I mean, we can't really control geographic location or the time of the year. I can't just scroll it back to yesterday. I mean, you can put cooling mechanisms in solar panels, but yeah, you could do that. But, you know, if you have air pollution in the environment around you, you can't really affect that. This is really the only one, other than actually making sure it's wired correctly, this is really the only one that we could have a physical control over to adjust power output. So why don't we go ahead, take this, I'm going to erase this question. We're going to leave all of this background information here. And now we're going to ask a different question. Because now we know there's a bunch of factors associated with power loss. But now we want to know specifically, how does this factor affect? So what would be a good next question? You have your hand raised?
Right now, I'm thinking about it.
Okay.
How does the orientation of a solar panel affect the output of energy or power?
Okay, there's Jason's question. Is this a good question?
Yeah.
It generally, again, is dealing with this observation. It's very specific. We're now more specific than what we were looking at. We're talking from the area of background research, and this gives us something new that we can do research on. Okay? So, plug that question into Google now. Let's see if we can find a few more pieces of information.
I found one that just logically isn't exactly correct depending on where you're at it.
Go for it.
So it says in general, solar panels that are oriented directly east or directly west will produce about 20% less electricity than if they're facing south. That's true of the northern hemisphere.
It is true.
The southern.
See, but you can justify that. You know what it's getting for. It says don't aim it in one specific direction towards the sun, away from the sun. Aim it south, aim it towards the equator. So we'll change that and we'll write it, aim it towards the equator. And you said 20% less?
Yeah.
Okay. You had your hand raised? You?
I just have a question. Why don't they just put it on something that'll rotate with the sun?
Hey!
I was just thinking about that too.
I mean, it's just...
Hey!
Plants
Well,
have been
Hey,
doing it
shh.
for
Here to
years.
here and then goes back.
Stop using those brain powers. Touch you guys too good at problem solving. We'll get there. Okay? First, we're going to determine whether or not it's even useful. Any other research that we can find about this? We just found out that you can get 20% gain just by pointing it south. 20% more free power. It's nice.
So the exact tilt of your roof,
Mm-hmm.
based on, the angle of your roof can also affect how much power is taken in from solar radiation. So if your roof has a pitch angle to it, then it could potentially add more rather than having a flat roof where it would just be facing straight up.
Okay. That's consistent with what I know. Anything else? All right, somebody give me one more fact. We're not going to move on until I get one more.
If it's upside down, there will be no power.
That is not, you did not Google that.
That is
Yeah.
a fact.
They simply don't make ones good. The highest efficiency rate they make is 22.8%.
Oh, we'll just have to figure out a way to get a better power output then, huh?
22%. Yeah, well, okay. Now we're getting into a completely different discussion. That,
Do you want another?
give me another one.
Panel itself.
On a standard pitch roof facing east or west will produce approximately 15% less output than panels mounted the south facing the roof on a standard pitch.
Okay, that goes with this one. Similar numbers, 15 to 20%, but that's still pretty substantial. Two different sources saying the same thing. Okay, so now what we have is we have a bunch of information. We gathered a lot of this just from our first question. We gathered very precise information from our second question. This is more geared towards what we would do to set up our experiment now. This is telling us, hey, based on what we're seeing here, does the orientation of the solar panel affect its power output? Yes, this is very clear. I mean, you're looking at 15 to 20% extra money. Now, granted, you do have this 22%. It can never get better than that. That is, they do sell some solar panels that can get up to 40%, but 22% is the most commonly commercially available panels.
Yeah.
And it's bad. Basically, that means that plants are better solar panels than what you have, and plants feed themselves off of light.
Hey, plants have been doing this for millions of years now.
Yes, they are, and they continue to do it.
Have they ever thought about observing and maybe trying to mimic that of a plant?
Yes. In fact, that was the whole idea behind the solar panel.
I mean, like,
Yep.
literally like mimic it.
Yeah.
Flower.
Really channel your inner flower.
Fight the power, sunflower.
There you go. Okay, so we've got the background research that answers the question. The next step of what we're going to do, I'm going to go ahead and erase this. What is the step after doing background research? We come up with a hypothesis. So, for this hypothesis, what is our hypothesis going to be? What?
Let's just make better ones with better efficiency.
You know what? If you do that, you can make a ton of money. Again,
I'm gonna do it.
I keep introducing you guys to topics where it's like, all right, everybody thinks solar energy is great. Solar energy sucks. It is awful. It can have so much better improvements made to it. We just haven't done it. So if you can figure out a better way of doing it, go make money. Go forth.
I'm gonna do it.
Use your knowledge.
I'm gonna put a nuclear power plant in my backyard.
Well,
That's another Chernobyl. No,
nuclear power is surprisingly
way better.
efficient, effective, and clean.
Somehow you can reuse the old stuff.
Yes, you can.
Well, yeah, because it just
The old stuff.
reacts over. I know the name for it. I just don't want to decide it would be used.
All the nuclear power cores do is generate heat. That's it.
You just have to have some sort of water.
Heat can also be turned to energy.
Yes, through a steam cycle.
Yep.
As long as you have a steam cycle, you can turn any source of heat into it. Nuclear energy just happens to be a source of heat that doesn't have any waste.
And it gets really hot.
It does get really hot, and if you don't have the proper water flow, that's when you get the meltdown to happen. Japan, they had a tsunami about 12 years ago and had their nuclear power plant melt down because they ran out of gas in their backup power generator that cycled water. That was it. For want of a tank of gas, their nuclear power plant shut down.
Should have been on solar.
Japan doesn't have a lot of space for solar plants. Huh? Okay, so what's a good hypothesis? We've got our question now. What is the hypothesis that we can state here? Now, do keep in mind, a hypothesis needs to be testable, needs to be realistic.
The orientation of a solar panel affects the
I'm going to use the word angle. We do. We are going to do it again just because at this point, dang it. You guys need to stop thinking for yourselves. Just conform, man.
This is how. This is what you say. You need to turn your camera so that the people on Zoom can actually see what's going on.
They can see. I specifically made sure that they can see all the way out to here. They just can't see me.
Okay.
I'm like an invisible force that keeps inserting his hands into the video.
Okay.
Ah. Okay, so we're going to go ahead and assertively state the angle of the solar panel affects how much power is output. Okay? Now, is this testable?
Yes.
Is this realistic?
Yes.
And we know it's realistic because we've found sources that tell us exactly that. That's awesome. There have been experiments done on this, but it does vary the results on these very wildly. So in some respects, it is better to do it yourself if you have a bunch of solar panels, because you may get different results than what anybody else is telling you based on where you're located, your elevation, all these factors that you noted.
I wonder if the government would hate me if I built my own solar panels and didn't just buy them.
No. No, there's Elon Musk. He did. He built solar panel shingles to install on your roof. Yes.
That's awesome.
But that's what I'm saying. If you make your own instead of buying his,
No, because
He might be mad, yeah. Okay, so let's talk the next step, and this is kind of an in-between step between hypothesis and experiment, is variables. What variables affect power output?
A lot of those.
I'm just going to start listing those out, but there are more that you guys didn't catch. Okay, first of all, wiring. If it doesn't connect well, air pollution, geographic location, time of year, and time of day. Temperature of panels. We've got angle of panels. This is going to be our independent variable. We got our power, which this is our dependent variable. All of these are going to have to be control variables. We got weather conditions. Okay, what other variables are going to affect power output of a solar panel? Brand of solar power, whoever manufactured it. Because 22% is the best efficiency from the best manufacturer. Yes?
The condition there.
Condition, yeah, the age. And whether or not they've been taken to a WWE mat recently. Give them the elbow. What other variables?
get out of this class. We don't talk about WWE in here.
I'm getting kicked out now?
You just kicked out the teacher. That's a thing.
The materials
I'm still going to give you tests, just from a distance.
the materials used
That's how
in
it's
making
supposed
the
to be anyway.
It's terrible. What?
materials used in making the
We're going to go ahead and lump that into manufacturer, because each manufacturer will make it. They try to make a very consistent product, but yeah, that is dependent on the manufacturer. What other variables?
Possible this amount of time to manufacture, but like cost.
Well, that would go back to manufacturer. But shape is a factor. You get a different kind of shape or size.
Sunflower shape gives more output.
Have you seen that one that automatically folds out?
Yeah.
Oh, so awesome.
Except that's, alright.
Hey, I already kicked you out of this class once.
Linda, that is a cool idea in theory, however, it takes energy to fold it up and unfold it to do it automatically.
That'd be a good point, but you use Internet Explorer.
Exactly.
No.
Well, I don't know.
Hey, they're already crappy, just don't get them.
They're already at 22% efficiency.
Batteries.
No, okay. So let's go ahead and say, yes, we could probably sit here and come up with more variables all day. Let's take these variables and let's come up with an experiment. Now, we're trying to determine how this affects this, which means ultimately what we're looking for is a mathematical equation whereby power is given as a function of the angle. Okay? We do not want to know how the power is affected by the time of day, time of year, geographic location, elevation, air pollution, wiring. We don't want to know all of those factors. All we want to know, all we want to change is the angle of the solar panel to find how it affects power. So what is going to be the experiment that we could run to try to determine this relationship?
Angle equals 1. That's the only way this equation works.
What?
The only way this equation works is if angle
That's-
is equal to 1.
This isn't a multiplication. This is a function.
Yeah.
There. Does that make it look like a function? Now it doesn't have to be 1.
You could have two completely identical solar panels and simply have one at a different angle than the other.
Okay?
All the other factors the same.
Now the issue that you may have is that each individual solar panel might have some differences. So how would you account for that? Yeah.
Alright, so to raise Jonathan's answer to another power, 180 different solar panels, each at a different degree, to measure every single degree.
Well, that would be very expensive, but if you're doing this research because you're trying to install maybe 4,000 solar panels,
1,800 solar panels so that you have 10 at each degree, and therefore you can account for variability.
then you would be able to have an average of 10. Okay, so yeah, we're gonna go, he's taking your idea, just making it a lot more expensive. Okay, so the experiment is 1. Obtain 1,800 solar panels. We're going to eventually purchase probably 4,000. This is a solar panel farm.
Step 0, bank heists.
Yeah. Hold on, I'm robbing the bank so I can save the planet. Just give me your money because it's worth it.
That is some Florida man level shit.
Florida man robs bank, saves planet.
As long as you attack it with an algorithm.
Exactly.
Tens.
There we go, thank you.
What if anybody's ever believed those stories about Florida man?
I don't know, you can find it on the news. And we all know, news is always 100% reliable.
Well, that's reliable as Wikipedia.
That's where I get all my news. Okay, so here's our experiment. Does this experiment account for all of our variables?
No.
Okay, first of all,
Do it in a box.
what?
You have to do it in a box.
Do it.
I guess a room.
How would you get this out?
It doesn't necessarily have to actually be the freaking sun. If you use a lamp, that emits UV radiation,
They would solve the temperature problem.
it would be a lot easier to control what's going on in a room than putting it outside where temperature is going to change, the weather is going to change in a room.
That's
They're
true.
all in the same conditions.
That is also true. Technically,
If you're taking it over only one day or one, so, all right.
Over 1 week.
Oh, I guess if you do it all at one time, then it does factor in.
We bought 1,800. We might as well measure them all.
I mean, what if I multiplies two every time he's outside? Like, you control that variable, but like every time he's outside, one then.
You can't control it at that point.
What if the plant gets up and walks over to one of the other solar panels and you not know it?
I'm about to take a roadie to the
You guys are having a great discussion, but that was ridiculous, Jeremy. So, okay, well, what we're going to end up doing is, no, we can't control most of these, okay? When we go take measurements, we can write down what time of day we're all going to be at the same geographic location. We can write this down. We can write this down when we take a measurement, okay? This is going to be consistent for every single panel. This hopefully is going to be consistent, although we're going to have to check that, okay? Weather will be consistent. So even though we cannot control some of these, because we're taking multiple measurements at the same time with different systems, you're right. You're right. This does account for the control variables even though they differ. And what you end up with for your data output is you will end up with 180 different graphs, which I'm not going to draw 180 different graphs because it's Friday. Well, let's say I come up, here's 4 graphs. This is from something that's located at 15 degrees. This is 60 degrees. This is 120 degrees, and this is 180 degrees. Okay, something like that. You know what? It does bother me too. You're right. This 45s.
There you go.
Okay, although we're missing one for 0.
It's fine. It's fine.
Should have done.
0 will be the same as 180.
Technically, shouldn't it
Maybe.
be negative?
But it's pointing east as opposed to west.
Yeah. Just draw one more.
Oh, 0. Okay. Oh, but now it's out of sequence. Okay, so I'll start with just follow me here. I'm not redrawing this again. I'm trying to get you out of here. Okay, so we're going to put at 0 for our 1 day sequence. Looks like this. Okay. For 45, for a 1 day sequence, looks like this. Okay. For 90, for a 1 day sequence, looks like this. For 135, 1 day sequence looks like this. And then 180.
Hey, at least we flattened the curve.
Yes, we solved that Rona. So this is the data that we have now available to us. Can we say that this hypothesis is true or false?
True.
It's true because we're able to show that just by changing one variable, these graphs are all different. They should all be the same if the angle doesn't matter. What are the implications of this? No, that hopefully is not the implications.
That it should be angled.
That if we control the angle of our system, we should be able to increase or change the power. Okay, this is where, yes, you're right. You got way ahead of me because you pointed out the end solution before we went through the entire process. If you had a solar panel that tracks the sun, this is where you can get your 22% efficiency. That's how you get 22%, by the way. Otherwise, you're looking at maybe 5% efficiency throughout an entire day cycle. Maybe. Okay, yes, it does cost energy to do this, but the difference between 5% and 22% is a factor of 4. You have a really low power motor that's in there controlling your power output. You are making more energy by consuming energy. Yeah.
if you had a water-cooled, or any kind of fluid-cooled solar panel, and then you put a magnifying glass in front of it and turned it with the sun, how much power output would that give you?
If it can handle that amount of solar radiation, they actually do stuff like that. Some solar farms, they have parabolic panels that are located on the sides that direct sunlight into the center. They do that. And they are able to generate more power. But you're right, they do also have to cool it down because you're frying. Just.
So it's ants in an anthill.
Yep. You just go out there and throw some popcorn kernels out. Delicious.
And you can get a quick sun from
Yes, very quick. Better rotate quickly. All right. So next week, Monday, we're going to be talking about our formal presentation on Friday. Wednesday. Wednesday, you will have to dress up. Interview your partners. So do keep that in mind. Any questions about this? Yeah.
Oh,
About that?
What do you mean by dressing up? You mean like come in here with like a...
Okay.
Formal wear.
It's a button-up shirt is generally considered dress up, preferably not flannel. Just something like this. This is considered a dress-up shirt. Slacks look nice. A belt if you're gonna tuck your shirt in. You can wear a polo shirt. Ladies can wear skirts, dresses. Those are also acceptable. You do not have to wear a suit jacket. If you want to go all out and wear a suit jacket, go for it. I don't like wearing a tie because I have a big neck, and this is very constricting. So I usually don't ever wear a tie. You can get away with that wearing a suit jacket sometimes, but it's generally best if you're going to wear a suit jacket that you also wear a tie. Okay? If you have any other questions, you can email me. Yeah.
Try my best.
If you try your best and you look professional, I'll be happy. This is one of those impress me with your dress. All right, any other questions?
Yeah, I know cross dresser.